It's Sunday, July 16th. Welcome to the intro video for Module 2, which is Pascal's Law and Force Multiplication. We'll start off uh, with objectives, as you should see on your screen. And it says we will need to, but when we're done with this course, we should have an understanding, I'll be able to demonstrate an understanding of Pascal's law and its applications in hydraulic systems. In addition, we should have an understanding of Bernoulli's principle and its application in hydraulic systems. Also, demonstrate an understanding of force multiplication and give me some examples. Define terms used in hydraulic system. Define them, know them. Don't memorize them. You don't have to. Just understand them. Be sure you understand them. Discuss advantages and disadvantages of hydraulic systems. There are a few, but hydraulics by far outweigh the disadvantages. We're going to start off with talking about a system. This is a cascading system. That means we have a prime mover of some kind of motor or diesel engine that's turning the shaft on the pump, which is making the hydraulic fluid flow, which meets a resistance like a cylinder, and it builds pressure until it actuates, and that's your system. Down here, it could be an electric motor, could be mechanical. It could be a motor, a hydraulic motor. Difference in a pump and a motor puts out a rotating flow that maybe we could call it something like a torque converter in an automatic transmission setup. But it gets a rotating fluid. This is a linear flow when we're using these hydraulics through lines. This motor would put out a rotating flow to a pump or anything that would in a pump, and the pump would start doing the same thing, putting pressure, putting flow out until it meets resistance, therefore increasing the pressure, and as a result moving, digging, hauling, pulling, whatever you need doing. So 3 things to know about hydraulics. The system is powerful. I mean, really powerful, and it's pretty easy to make it more powerful than it can stand. So you have to be careful with hydraulics. I have a small farm tractor that if it'll tear itself up if you let it. It's precise. You can move it a fraction of an inch, and consistently increments. The valves and things they have come out with now make it just amazing. It's stable, it's solid, it's incompressible. You can't mash it. Air, you can a bit. So having said that, when we talk about fluids, there are 2 kinds. There's liquid, that would be hydraulic fluid, and there's gases, that would be pneumatic, that would be air. Right, but this is an illustration. If this was an enclosed system, this was a piston and it was sealed, you could set a building on top of this and it would never move. I don't know much about thermodynamics, but maybe heat would cause it to move, or I doubt if it would not compress. So that's what we're trying to get across here. It's incompressible. So I said I was going to have a kind of interpret the book a little bit as we go through, but not spend much time on it. So we'll start out. This is about the first 3 pages of the chapter 22, and these are things within those first 3 pages. Force multiplication. Hydraulic systems can be compared to mechanical systems that use mechanical advantage to multiply force through leverage. Figures 22-4 and 22-5 on page 532 of your textbook, Fundamentals of Mobile Heavy Equipment, is a really good illustration. But when you multiply force multiplication is a trade of distance and or speed for force. You're going to lose a little distance in how far you can move it, or a little speed in how quick you can move it. So that's the trade-off. That's the cost. The mechanical system uses leverage from like a fulcrum. The hydraulic system uses fluid pressure that's pushing against the cylinder. Now, force multiplication, this is a real simple one to work with and go through with you right quick. So we have, this is one system right here. I have a smaller system with a force of 200 pounds pushing down. I have an area here, we'll call it A1, of 4 square inches. Over here, I have a cylinder that's 8 square inches in surface area. So I have a lot more area on this side. We'll call this force 2. So go back over here. Let me talk about this little triangle first. This is like to help you in transposing. If you have been through algebra, you will know about transpositions. Like you have an equal sign, and you want all of the letters on one side and all the numbers on the other, or this thing you're looking for on one side and everything you need to get it on the other side. But moving it across the equal sign requires a little bit of calculating or differentiating. So the use of this triangle is your 3 variables are indicated here: area, force, pressure. All right. So we know the area for one of these is 4 square inches. We know the area for the second one is 8 square inches. So let's start with force 1. And what we're looking for is we're trying to lift a load. And let's see what force we can get out of this, so we can see what load we can lift. So what we need to know, we have the force, we have the area, so we need to know what the pressure is throughout this. And I can promise you, whatever it is here, it's going to be the same here because it's connected by a hose tube or something. So let's take the force, F1, 200 pounds, and divide it by the other known factor, the area, 4. So 200 divided to, let me start over. 200 pounds of force divided by 4 square inches is 50 pounds per square inch of pressure here, and you can bet your boots it's over here. To prove it, 400 pounds of force is coming out of here. The area is 8 square inches. What is 400 divided by 8? Can you guess? I'm going to calculate it. If I can find my calculator. 400 divided by 8 equals 50. 50 pounds, 50 psi's. So we have 50 pounds of pressure throughout the system. We're pushing down with 200 pounds of force on 50 pounds of pressure. So what are we going to get out of that? We're pushing down with 200 pounds here. We have the area here. It was really not going to make that much difference, only in finding what the pressure is. But when we get over here, we have this 50 pounds pushing up against 8 inches. Now look at the formula. Pressure times area equals force, and that's what we want to know, what force 2 is. So let's take the pressure of 50 and take the pressure of 50 pounds per square inch and multiply it by an area of 8 square inches. 50 times 8 equals 400 pounds. There you go. So we took 200 pounds of force, we pushed down, created 50 pounds of pressure, And 50 pounds of pressure pushing up against 8 square inches gives you 400 pounds of force. And there it is, folks. That's the course. No, really, this is to get you to understand Pascal's law and its applications. This is the very beginning of it. We will get into speed of actuators. We will get into distance, like how far, if you push this down 10 inches, how far is it going to move? So you know the factor is 2 to 1. If you push it down 10 inches over here, it's going to move 5 inches over here. So see, you got to push it further just to get half the distance. But you get 400 pounds, you get twice the force. So if you have a 350-pound thing, object that needs lifted, you can lift it with this system right here. So let's move on. We'll get into calculations a little bit more. Hydraulic system terminology, there's a whole list in there. Forget exactly what page it is, but it's within those 532 to 534, I think. It'll be in there. So again, don't memorize it, but understand them. Let's look at advantages and disadvantages. Right, I've got 4 really neat advantages. It's low maintenance. It has a multiplication force effect. It's extremely flexible. You can put a lot of conduits in a little bitty place. If you've ever worked on an excavator, just imagine if that was 1-inch pipe that you had to thread and calculate elbows and things. So it's real flexible. The rest of the advantages can be found along on those pages I got listed, 533, 534, along with the rest of the advantages along with disadvantages. It's messy if it leaks. It's EPA issues at stake. So it does have some disadvantages. Please look over those. And Pascal's law in particular, it's really brief. This is what it says. Pressure is distributed undiminished. It doesn't drop. Pressure doesn't drop throughout a closed system or container. And it puts equal force on all sides of that container. And that's Pascal's law. You know, it's the flow starts out as flow, and when it meets resistance, such as a piston or in other actuators, it's going to start creating pressure. And here's that formula again. Bernoulli's principle talks about, it applies to hydraulics as well as aviation, because what it says is a rise in pressure in a flowing fluid, which could be air or hydraulic oil, must always be accompanied by a proportionate decrease in the speed of that air or fluid. An increase in the speed or flow rate of the fluid results in a decrease in pressure. Think about an airplane wing. When the air hits that wing and goes over the top of it, it's slowing the flow down. It meets resistance going over the top. So what happens underneath that wing where it doesn't have that resistance? We're decreasing the flow going over the top of the wing. So underneath the wing, we're increasing the pressure. And that's what's keeping that airplane up. It's Bernoulli's law. Get a garden hose out in the backyard, take the nozzle off of it, turn it on, and you got a pretty good stream coming out of there, about the same diameter. So you got a really, really good flow rate coming out of there. Now take your thumb and cover half of the outlet up. What happens? Well, you cut down half the flow rate, but what else happens? You can squirt it a long ways. You've increased the pressure. That is Bernoulli's principle. Now, its applications are yet to be discovered, but we will as we go along when we get into some valves and things like that. One of the things the book talks about is if you change out a hose, you ask yourself this, thinking about Bernoulli's principle. Does it matter what size hose you put on and replace the one that's damaged? What if you put a hose on that has a larger ID? You're going to increase the flow, but you're going to what? You're going to drop the pressure that you need. You put one on that's got a smaller ID, you're going to restrict the flow. So you're going to have an increase in pressure. You're going to mess things up. You're going to mess the system up. Valves now have things that so the fluid can flow through the valve without having this two different pressure on each side, so that you don't get a lot of clatter, or what do they call that? It's kind of word. Anyway, like when your pipes rattle in your house. Anyway, that's Bernoulli's principle at work. You got a big flow going into a little diameter, so you're going to create some problems. Uh, I don't want to go any further. Uh, Tired of talking. That was pretty quick, but you got a real good peek at force multiplication. You got a good idea of Pascal's law, and there's a little bit that you've gained from Bernoulli and his principle. So I'm going to try to come up with a wrap up of the module 1 in both courses. So if you have questions and you're enrolled in ER 101, which is soil and erosion, or you are enrolled in hydraulics 101, HYD 101, you're in hydraulics, and you're in my class on both occasions. I teach both those courses. So give me a call if you get in trouble. If you have some issues that come up that prevent you from keeping up, we'll work something out. I just need to know. Self-advocacy is the secret to success in an online learning course. Self-advocacy is speaking up for yourself. Say, hey, I need some help when you need it. Have a good rest of the weekend, and let's have a good week. Get some things done, some things learned. See y'all.